So we are going to go through the coach questions. We are on use nets to find surface area, coach. And the first question says, use the triangular prism below to answer the questions about surface area. So when we talk about surface area, what we are talking about is taking this object and basically laying it out flat, okay? So when we lay a triangular prism out flat, it actually looks like this. So you can see that we have two triangles and we have three rectangles, okay? So we know that the front triangle and the back triangle are absolutely the same. So when we do this, we know that we just have to do 6 times 4. 6 times 4 gives us both of the triangles together. So that means that it's 24. Then what we need to do is we need to figure out the area of the sides. So we know that this side, the length is 10 and the width is 5. We also know that the other side over here is also 10 times 5. So we have 10 times 5 in this case, which is 50. And then we do 50 times 2 because we know that it's two sides that have a width of 5. So that is 100. The only side that is different is the base. We see that the length is still 10, but the base this time is 6. So we have 10 times 6, which is 60. So what we're going to do is we're going to add all of those up together, and we should get 184. All right, so in the first box, what we're going to do, and I'll go ahead, oops, sorry about that. We're going to actually type in 184 into this first box. All right, so we know that the surface area of the triangular prism is 184 square units. Now it says if the longest dimension of the prism is decreased by 1/2, so that means wherever there's a 10, instead of 10, it's actually going to be a 5, okay? So instead of writing this all out to get, at once, one more time, I'm actually going to just cross out all my 10s here and put a 5. So then that means that this is 25, and then that means that 25 times 2 is 50. So I'm changing the second question to a blue. And instead of a 10, this is a 5, and cutting 60 in half is 30. So again, we're gonna add up 24, that does not change, 50 and 30. And when we do that, we now get 104. So we're gonna check my answer, and we see that we are completely correct. So that is the answer for question number 1. Let's go ahead and go on to question 3. So question 3 says, identify the combination of shapes that can be used to form a square pyramid. So what you might want to do is go back to this one, which is a square pyramid, and we may not have oh, there we do. A square pyramid right here. So we can see that we have a triangle, 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 and a square. So we go back to this one, triangle, triangle, square, 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 no. Triangle, 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 square, square, no. Triangle, 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 square. Triangle, 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 square. So I'm gonna go ahead and look at this again. Triangle, 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 triangle. So that means we have to have 4 triangles and 1 square. And I check my answer and I see that I am correct. All right, that's question 3. Question 4, it says, look at the measurements of the rectangular prism below. So we can see that we have a rectangular prism here. So similar to the last one, we know that we have to look at it when it's kind of unraveled. So I'm gonna go ahead and show this to you again. This one right here. All right, so we know that we need to do length times width, length times width, length times width of each one, okay? So we know that a rectangular prism has 1, 2, 3, 4 long rectangles and 2 squares. Okay, so when we look at this again, we should see that the ones that are correct are the ones that do 2 times the length and the width. So this one, B, is automatically correct, and that one is probably the easiest one to see. Then what we can see is that C is actually correct too, because we're doing 5 times 11, 5 times 2.5, 11 times 2.5, but then we are taking it all and timesing it by 2. And then the other one that is correct is actually D. The reason why D is correct is this one and this one takes into consideration 2 times that. This one and this one and this one and this one. So it is actually 3 answers, B, C, and D. All right. Next one is number 6. All right, number 6 says drag each net to the most specific name of the figure that it represents. So automatically I can see that this one is a rectangle. So I'm going to drag this one to a rectangular prism. This one I can see is a perfect square, so I'm going to drag this one here. Now what we need to do is decide between a cube, a triangular prism, all right, and a triangular prism. So we have rectangular prism, square, square pyramid, I'm so sorry. This is a cube. All right, square pyramid, okay, we look at these two are the ones that you will get confused with probably the most. The square pyramid and the triangular prism. This one is a triangular prism because it has the 3 like rectangles and then it sits on a triangle. This one, the base is a square. So whenever it says square, we need to look for the square first. This one is a triangular prism because it sits on a triangle, okay? So we check our answers and we are correct. The last one is 8. And it says, if the rectangular prism shown below were to be altered so that the 6 inches length is now only half the value. So that means that it's only 3 now. Determine what happens to the areas of the faces and the surface area of the prism. Classify each area and the surface area after the dimensions has changed by whether it would remain the same as in the original or become half the value of the original or neither. Okay, so we should know that the total surface area, neither, that is the one that is neither, meaning it's going to change completely, okay? The same value we have as the area of the front rectangle. So that front is not going to change at all because it's not being halved, okay? We also know that then the area of the back rectangle, which we can't see, will not change at all either. But we do know that the area of the bottom rectangle, okay, what it's sitting on, that will change. It will get smaller. We also know that the area of the top rectangle, the one that we see right here, that will change because it will be cut in half. And then we also know that the area of this side rectangle would change obviously by a half because we are cutting it in half. All right, so we have same value, half of the original value, and neither. Okay, I'm going to check my answers. All right, so that is all of the questions for the coach today. All right, guys, I just finished recording. Does anyone need me to go back and show you the answers again?